All right, so this is AP Calculus AB Unit 7 Pretest. This is the key, the solutions. Notice that not all of them were out of 9 points, and some of them I gave extra credit. On the actual AP test, they will all be out of 9 points. All right, so number one, it's a calculator question. It's the only calculator question that we have. So I'm going to open up my calculator, file, open recent, TI-83 plus. All right, so I'm using a slightly older version of the calculator, so yours will be even easier. The first thing I'm immediately going to do is just plug it in because I know I'm eventually going to use it. So this is a negative, so use a negative, not the minus sign, and then in parentheses, x minus 1, n parentheses, x minus 1, n parentheses, that's x plus 1, what am I doing? X plus 1, n parentheses, times sine of x squared divided by 2. All right, so this is what it looks like on TI-83 plus. I'm going to second quit out of this. My window, do I know what my window is? It doesn't say anything, so I'm just going to leave it as the default for now. I might not even need to graph it. All right, so coming back here, find the acceleration at t is equal to 2. So I'm trying to find a of 2. I'm only given velocity, so I need to say, okay, that's equal to v prime, and that's just a definition. To get to acceleration, I take the derivative of velocity, again, at 2, and then that's just a calculator problem. The way that you do that is you're going to do math 8, and then do everything from there. So math 8, and that's the derivative. On my calculator, it's a little bit different than yours, so I'm going to hit var's right, enter, take the derivative of y1 with respect to x at time is equal to 2, and hit enter, and it'll tell me, hey, my derivative is 1.588, rounding. So this is equal to 1.588. But then it also asks you, is the speed of the particle increasing at t is equal to 2? So I have to check my acceleration and I have to check my velocity. So I check acceleration. So there's an actual shortcut to doing this instead of looking at the graph. And here's your shortcut. So acceleration of 2, the way that you do this is you type in y1 of 2 in your calculator. So I'll put like a box around that. That's a calculator thing that you can do. So that's what it looks like over here. Var is right, enter, y1 of 2. And it tells you, oh, the acceleration, or sorry, that's velocity, isn't it? What am I saying here? This is velocity of 2. We already know the acceleration of 2 is, the acceleration is 1.588. The velocity at 2, since this is the velocity, to plug in 2 into this equation, the way that you say that on the calculator is what I just did right here. You say the velocity of 2, that's negative 2.728. So that's equal to negative 2.728. You don't actually have to have the number, but I'm showing you, hey, one of them is positive, one of them is negative. That means speed is decreasing, so it's not increasing. So the answer here is no. And maybe I should type this out because it'll look a little bit better. We'll say no, the speed is not increasing because v and a have different signs. Cool. And then the way that you would score yourself, you get 1 point if you say 1 point if you found 1.588, and you get 1 point for saying no with the reason of v and a have different signs. So having v and a different signs, that's part of it, and then saying no, both of those will give you +1 for here and for here. For part B, find all times when the particle changes direction. So it's just a definition. What is change in direction? And that's a v sign change. So I have a calculator. Let's go ahead, and I do need to graph it. I'm just going to leave the window the way it is, so I'm going to zoom 0 and hopefully it'll work out okay. Oh wait, between 0 and 3, my window's, okay, so I'm going to hit on to quit it, and then I can go window 0, enter, 3, enter, and then do zoom 0. Alright, so while that's graphing, again, v sign change, that's going to be where it crosses through the x-axis. In this case, it's going to be a t-axis because all my variables are t. So where does it cross through the t-axis? And it's right there. To find that exact point, again, to have it for your notes, it's going to be math, or not math, it's going to be, sorry, second calc 2. Second calc 2 will get you to do, or it's not calculated, second trace to, but it's you're calculating the 0 values. I'll come back and fix that in a sec. And then I'm going to say my left bound, sure, enter. My right bound is 3, I guess, the far right, and any value in between, I don't know, 2. And then it'll tell me 2.507. So at t is equal to 2.507. Let me come back up here and change this to second trace. And then you do need to justify your answer, and you basically need to restate this. So you'll say, because v sign change. In terms of what I'm looking for, if you somehow write v sign change off in the top right corner, and then you write t is equal to 2.507, those are connected, so I will give you the points. But it is better if you write it all out in one place for the AP graders to make sure they don't miss it. It's all right there. So in order to score yourself, you get 1 point for getting the time correct and 1 point for getting the justification. So that's out of 2 points. That was out of 2. This upper one was also out of 2. Part C, total distance traveled. Again, another definition, total distance. Total distance is going to be the integral between 0 and 3 in this case, 0 and 3, of the absolute value of your velocity, vt dt. And I know on the speed sheet I just say absolute value of v, but we're being formal on the test, so I actually need to do this. So I come back here to do, let's get out of this. So I'm going to do math 9. I'm taking the integral of absolute value of that y1. So do math right, enter, enter, absolute value, let's go to absolute value of vars right, enter, enter, absolute value of y1, and the parenthesis here, with respect to x from 0 to 3. And it'll take a while to do that, but what you should have gotten was 4.334. 4.334. The way that you score yourself is you get 1 point for finding 4.334, and you get 1 point for having all of the integrand correctly, and by that I mean the absolute value of v of t dt. All of this stuff right here is 1 point, and then another point if you get the bounds correct. So this is a total of 3 points for this question. And let's go ahead and see, yeah, 4.334 rounding. So part D, we're looking for the greatest distance. Whenever you see the word greatest or least, you need to be thinking minimum, maximum. You need to be thinking make a table. So let's go ahead and make a table. I'll go ahead and make my lines here. And I have my t value. I know that the 3 things that I always need to check whenever I'm looking for the greatest distance, this is again on your speed sheet, you need to do your start, you need to do your end, and you need to do any relative extrema. So our relative extrema from our graph, if you remember, was this point where it crosses through the x-axis, and we already calculated that. It's 2.507, so 2.507 needs to be on your list, and I guess 2.506 would also work. They don't really care if you truncate around here. Again, you're doing start plus change in order to find your end value. And we're looking for the greatest end value because the greatest distance. So our start, where do we find that? It's up here. Always check what your start condition is. It says the position is at x equals 1. Come up here and label that. That's your start condition. Your start condition is 1. So I come down here, my start is 1, 1, and 1. Okay. The way that we do the integrals, I always have the lower bound of whatever it says up here. My lower bound, I start at time is equal to 0. Again, that's another start condition. This is a start position. This is a start time. But they're both conditions that you need to be aware of. I'll put a time up here in parentheses, and I'll say a position up here in parentheses. There's a start position and a start time. So my time is going to affect my lower bound of the integral. So down here it's going to be from 0 to whatever, plus the integral of 0 to whatever, plus the integral of 0 to whatever. And then the whatever up here is going to be whatever time I have over here. So it's going to be 0 to 0. This bound right here is going to be 2.507, 2.507 for the rightmost interval, and then 0 to 3. What am I doing? The integral of velocity. And I'm not going to be formal about this because you don't need to be. I'm just going to write v. It's a waste of time to write v of t dt in my opinion. So I'm just going to go ahead and write it like that. Whenever I have the same bound to the same bound, that's gone. 1 plus 0 is 1. Now I have to do this with my calculator. I have to take the integral between 0 and 2.507 and add that to 1. I can do that all in one step. I can say, let's clear out that, 1 plus math 9 of vars right, enter, enter, of my y1 variable with respect to x from 0 to 2.507. And hit enter. And it's already adding in the 1 for me, so I know what my end value is. My end value is negative 2.265. Negative 2.265. All right. And then finally, I do the same thing with this lower bound. I haven't calculated it anyway. I have, yeah. I've already, no, that's the absolute value. Darn it. Okay, I have to do it again. So a cool little shortcut for you guys is if I do second enter brings back the previous line that you wrote. And if I hit second enter again, it goes even farther back. So again, second enter goes to the previous line. I keep hitting second enter. Well, now I've gone too much. I don't think there's a way to go forward. So I'm going to have to re-enter this again. But that is a cool little shortcut to repeat the last line. I would do 1 plus math 9 of vars right, enter, enter, my y1 function with respect to x from 0 to 3. And I hit enter, and it tells us that's negative 1.197. Negative 1.197. And again, which one is the biggest out of all of these? Sorry, the greatest distance between the particle and the origin. So in this case, the answer is going to be what's the farthest away from 0. You're basically taking kind of like the absolute value of whatever this distance is. I started at 0. No, I started at... Let me think about this.
We didn't watch the morning announcements.
Say again, Arrow?
We didn't watch the morning announcements.
Ooh, yeah, let's do that right after this problem. I'm trying to find the greatest distance between the particle and the origin. And, yeah, what's farthest away from the origin? Well, negative 2.265 is farthest away from the origin. So I come down here and I'm going to say, okay, yes, that's my answer. Let's go ahead and write out our answer in words so the AP graders know exactly how to give us points. We say, yes, negative 2.265 is the greatest distance from, or maybe between the particle and the origin. And happens at t is equal to 2.507. They're not even asking for the time, but I'm going to put that in my answer because sometimes they ask for the distance, sometimes they ask for the time, sometimes they're asking for a position. If we write all that information, we will get it correct no matter what. So how do you score yourself for this problem? Oop, I don't know what happened there. That's my old key. To score yourself, this one is going to be out of 2 points. You get 1 point for saying yes, negative 2.265. So you get 1 point. You can maybe just circle it, but it's better to write it all the way out. And then you get 1 point if you were somehow writing down this integral, the integral from 0 to 2.507 of velocity. So if you said that, go ahead and give yourself 1 point there.
Mr. Zimel,
Yes.
I think I did the integral. You gave me 0 points on this one, but I'm confused of how that second point was taken out.
You wrote down this integral 0 to 2.507v.
Yeah, I think so.
I should give you that point back then.
Okay.
All right, so that was number 1. Let's move on to number 2. So immediately we have to find the acceleration. Again, we don't have any calculator, so I might as well come out here and quit out of that. The acceleration at time is equal to 1. I'm looking for a of 1. So what is a of 1? Well, I don't have a, I have v, so how do I get to a from v? I take the derivative. That's v prime of 1. So I'll eventually figure out what that is, but let's go ahead and figure out what v prime even is. So v prime of t, that's equal to, okay, I have something with a variable here multiplied by something else with a variable. That's my 1, that's my 2. This is going to be 1 d2 plus 2 d1. I'm using product rule. So what is 1? 1 is 2 minus t. What is the derivative of 2? This one tricked lots of you guys. Yes, e house, the doubter of e house is e house. E to the 1 minus t. But dinner of e house is the derivative of this, which is not 1. The derivative of 1 minus t is negative 1 because I have a negative t. So I have to multiply this now by negative 1. And then from here I can go ahead and add on the 2. 2 is e to the 1 minus t, and then multiply by the derivative of 1, multiplied by the derivative of this, which is again times negative 1. Another mistake, I guess, that might have been made, but I don't think anyone made that. Let's go ahead and simplify that just a little. No, I guess we don't really need to simplify. Let's just go ahead and plug in immediately. So if I do that, I'm going to come back up here. When I plug in 1 into the derivative, I'm going to get 2 minus 1 times e to the 1 minus 1 times negative 1 plus e to the 1 minus 1 times negative 1. All right, so this is 1, so just think of it as gone. 1 times anything is 1 anything. E to the 1 minus 1, that's e to the 0. Anything to the 0 is 1. So 1 times negative 1. That's negative 1. Again, 1 times negative 1 is negative 1. Then e to the 1 minus 1, so I'm going to do plus here. I guess it's going to be minus because this negative is going to be distributed. So minus, and then this is 1 times negative 1, which is negative 1. What is 1? Negative 1 minus 1, and that is 2.
0.
Negative 1 minus 1, you can think of it as a keep, change. So negative 1 plus negative 1 is negative 2. That is what you are looking for, a negative 2 there. So to score yourself, you get plus 1 point if you actually found that that was negative 2. And you get 1 point just for writing that you're going to attempt to find the derivative of velocity. You don't actually have to take the derivative correctly. That's where this point comes from. So that one was out of 2 points. For part B, we're looking for if the speed is increasing. So speed increasing, what is the definition? We're looking for V and A to check if they have the same sign or different sign. If it's a different sign, that means they're going to be decreasing. So we're looking for the same sign. That's going to be increasing. Well, check it out. We have acceleration. We know that acceleration at 1, we just found up here is negative 2, so that's less than 0. Now we need to find the velocity at 1. And if that's less than 0, then it's increasing. So I come back up here and I'm plugging that in, or I'm plugging 1 in. So I'm going to come over here, I'm going to say that is equal to now, and it's this equation, so 2 minus 1, and then e to the times e to the 1 minus 1. And simplifying that just a little bit, 2 minus 1 is 1, e to the 1 minus 1, that goes to e to the 0, which is 1, and 1 times 1 is 1, which means this is greater than 0. 1 is less than 0, 1 is greater than 0. They have different signs. Different signs means the speed is decreasing. So I'll come down here and say, no, it is not increasing. No, the speed is not increasing because A, or I can say V and A have different signs. And there's a lot of different ways to say this. Some of you like to say, you don't even have to say V and A have different signs. I appreciate it if you say that. You can just say V is greater than 0 and A is less than 0. That's the same way of saying that. But I'm going to leave it like this for now. How to score yourself. For part B, you got 1 point for saying no, or it's decreasing or something like that. And you get 1 point for saying V and A have different signs in whatever way that you choose. So again, this one was out of 2 points. Part C, find all values of t where I have a change in direction. So change in direction, the definition is I'm looking for a v sign change. And that can only happen, I'll put in parentheses here, which happens, not writing this, happens when v is equal to 0. In order to have a sign change, I definitely have to have v is equal to 0, so that's what I'm going to do. I'm going to set this v right here to 0. Let's copy it down. So what is it? 2 minus t times e to the 1 minus t. What's going on here? 1 minus t, and I'm going to set that equal to 0. And this is kind of a cool trick. So this is an exponential function. An exponential function's definition is I have some number for the base and some variable in the exponent. I have a number, e is 2.718281828459045, all of that. And t is the variable, so this is exponential, and exponentials will never ever be 0. So go ahead and make a note if you want, never 0. Never 0. This guy right here. So I can't use the 0 product property if that can't be 0. The only thing that could be 0 is 2 minus t is the only thing that could be 0. And then I solve that, I add t to both sides, and 2 is equal to t. That's the only place where I could have a v sign change. But what if it just comes here at 2 and touches and then turns around? We don't know that it actually crosses. In order for it to change direction, it has to have a sign change. It has to cross through that t-axis. So to check, you come out here and you make a number line. And I say, okay, this is a critical value now. The definition of critical value is wherever the velocity or f prime is equal to 0. And that happens at 2. And I check a value. What is a good value to check? Let's check 0. If I plug in 0 into this equation, do I get a positive or do I get a negative velocity? So if I do 2 minus 0, that's positive right there. If I do 0 over here, 1 minus 0 is 1. E to the power of 1 is just e, and e is 2.718. All of that, it's a positive value. So positive times a positive is a positive, which means I can come back over here and say that's a positive value. The only thing that's going to switch signs, again, this is always going to be positive because it's never 0. It's either always positive or always negative. Since there's no negative sign, this is always positive. I don't even need to worry about that guy. I only worry about over here. Well, let's choose a number that's bigger than 2. Or if you want to use the shortcut, this is to the power of 1. Whenever you have an odd power, it's going to flip, right? Or I could just plug in 3. If I plug in 3, 2 minus 3 is -1. That's a negative value. It does have a switching sign. I'll choose 3 in that case. So I'm going to come down here and write my final answer. My final answer is particle changes direction at t is equal to 2. And you have to say because v sign change. So how to score yourself? You get 1 point if you say, yes, you change direction at t is equal to 2. And you don't even need to justify it, but you should always check to make sure it is a v sign change. And you get 1 point if you say something like v sign change. All right, so we're moving on to part D now. And if I'm going too fast, just throw up your hand to throw on the brakes. But I feel like this is a good pace because you've seen these problems and you've done a really good job on the test. You know what you're doing for the most part. So write but do not evaluate. Oh, this is an easy one. So total distance traveled. That's the definition. So absolute value of velocity and integral of that. So let me actually do that formally though. So it's the integral from where to where? It's from 0 to 3, 0 to 3 of the absolute value of v of t and absolute value dt. And that's it. Yeah, you get a bunch of points for this one. You get 1 point for the bounds, 1 point for the integrand, all this inner stuff where you have absolute value. And if you got both those correct, yeah, that's going to be out of 2 points. This one up here was also out of 2 points. 2, 2, 2, and 2. So that was all out of 8 points. All right, we are on to the third problem. Again, no calculator. So this one was kind of interesting. There was a lot of reading to do, and you have to get that correct information. So the main thing to know is that, yes, this is a graph of velocity, and yes, it does touch at 0 right here, 3 and 5, 3 and 5. Yes, it does intersect the t-axis. But the bigger thing is that in the interval between 0 and 3, the area is 8. The area of the region bounded by 0 and 3, the area is 8, which means if I come back here, I say, yes, that is 8. Technically, it's -8 because it's below the t-axis. The next one is 3, so that means that this area is 3. And then finally, I have, I guess I should put my bounds up here a little bit more correct. So I have a bound here at 6. I can make that yellow. That bound, this area right here is 2, or I should say -2, because again, below the t-axis. So now that I know these areas, finding the integrals will be pretty easy. I don't even know what it's asking for in part A yet. Let's go ahead and ask. So find both the time and position when the particle is farthest to the left. That means if I'm doing farthest left or right, I'm always doing a table. Again, let's make a table. So here's my table. Yoink. It doesn't need to be too big because I need some room off to the right-hand side. Okay, what are the values that we always need to check for a table? What are the t values? We always need to do the start. We always need to do the end. Maybe I should do the end down here, which was 6 because it's 0 to 6. And then I need to do any time that I cross the t-axis. And again, you can probably ignore one of them. If I'm looking farthest to the left, that's a minimum. If I'm looking for a minimum, I'm really looking for where I'm going from a negative to a positive, which means this is a negative height to a positive height. This is the only relative extrema I really need to do. I don't need to do 5 because that's going from a positive height to a negative height, which is going to be a maximum or a farthest to the right type of answer. I'm going to go ahead and write it in here anyway, just in case. Like the general idea is if you don't know what you're doing, check every single relative extremum. So I have 3 and 5. But again, I only need to check 3. So I can make these lines slightly longer so the table looks proper. All right, so what is my start condition? My start time is 0, so I'll say that's my start in terms of my time, in parentheses, time. And this is my start for my position. So my start position, that's what I'm really doing right here. My start position is -2, -2, -2, -2. Next, we're going to do plus change. So this is going to be the integral from the start time. The start time up here is 0. So the start time 0 to whatever this time is, to 0. This is going to be adding each of these. So this is going to be the integral from 0 to 3 in this case. Integral from 0 to 5. Integral from 0 to 6. And all of these are velocity, 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 and velocity. All right, so to calculate these without a calculator, you're just looking at these bounds. Obviously, this one is going to be gone because it's 0 to 0, so this is just -2 for our end position. And down here, 0 to 3. So I'm doing the start condition, -2 plus, all the way here is -8. That's going to be -10. All right, from 0 to 5, 0 to 5 means I'm including this integral and, or sorry, this area and this area together. These areas combined would be -5, so -5 plus -2 is -7. And then all of the bounds, or all of the areas from 0 to 6, -8 plus plus 3 minus 2, that's really -10 down here, plus 3, which is -7. So -7 minus 2 is -9. All right, so we have all of our end values, and now we just need to do our answer. So I was looking farthest to the left. Which one is the smallest? Which one is the most negative in this case? And the answer is right here at -10. Let's go ahead and type out our answer. I have room down here. So we say that the particle is farthest to the left at t is equal to 3 and at position -10. All right, how to score yourself? We have 1 point if you just considered time is equal to 3. 1 point if you actually found that -10 was the farthest to the left position, so I can do it up there, down here. I guess I'll do it down here. Plus 1 if you said -10, and then 1 if you have if you actually found that time is equal to 3 is an answer. So considering it and then finding it to be an answer, each of those is individually its own point. This question was out of 3 points. So I'll come up here. This was out of 3. For part B, this one was hard. That's why I made this extra credit. This is going to be out of 0 points. Because I haven't really talked about this, I have to find an exact position at x is equal to -8. So know this. Whenever I cross this t-axis, there's no possible way for me to go any more in the right direction because I'm always going left. I'm always going right position for between 3 and 5. I'm always going to the left between 0 and 3 because I only have a negative area. There's no way to have like a little bloop of positive area. I think everyone can kind of understand that. So that means that these are kind of the locked in mins and possible maxes. So if -8 occurs anywhere between these values, that's the only place it could be. So where could -8 be? Is -8 between -2 and 10? Yes. Is -8 in between -10 and -7? Yes. And is it -8 between -7 and -9? Yes. And nowhere else. So it happens 3 times. But now we have to explain that in words. And we have to also state something along the lines of, hey, you're continuous. It says it's differentiable, therefore it's continuous. So I'll have to say something along the lines of differentiable implies continuous. Okay, now that it's continuous, I can use, what is the theorem that guarantees a height? This is a position. What theorem guarantees positions or heights? And this is all the way back to Unit 1, and the answer is intermediate value theorem. So I'll come down here and type in my answer, because there's a lot that you kind of have to say. So because the movement is continuous, and we know that because it was differentiable, by the intermediate value theorem, by IVT, the particle will pass through x is equal to -8. How many times? Well, at least once in each of these intervals, right? So I'll say at least once in each interval. And what are the intervals? So we have between 0 and 3, we have between 3 and 5, and we have between 5 and 6. I'm talking about the time intervals here, between 5 and 6. Let's explain more why. So we talked about how it's impossible for v to all of a sudden be positive in one of these intervals. Let's explain why. So because v doesn't change signs in each interval, each of the intervals that I just listed right here, right? The particle will only pass, I can't spell, through x equals -8 at most once per interval. So what do I mean by that? It's impossible to pass through x is equal to -8 twice in this interval, because you're only going in one direction. This is a monotonous, I think that's the word for it, monotonic? I don't know. It's only going in one direction. I can't all of a sudden have something like this where if I have a height of -8 right here, I pass through it multiple times in the same interval, because that would imply that I'm changing direction, and it's not changing direction. So that's what I'm really trying to say by this. It'll only pass through it at most once per interval, since I'm only going in one direction. I want to continue this explanation. Let me type. If I click on the T, there it goes. My computer is like dying right now. Come on, let me type. There it goes. And then we have to have our conclusion. It's 3, right? The particle is at x is equal to -8 3 times. Done. All right, and yeah, there's a lot there, and it is difficult. If you said one major piece of this, I can give you up to 1 point per piece. But yeah, again, that was out of 0, because that is a really hard statement to understand. You have to have the minimum, and you have to have the maximum. The minimum is for each interval. The maximum is it's only once per interval because it's monotonic, and then you answer 3, right? Okay, so for part C, this is asking speed, increasing or decreasing. So we're looking for the sign of v, the sign of a. If they're both the same sign, it's increasing. If they're both a different sign, then it's decreasing. So on the interval from 2 to 3, let's check down here. So between this interval from 2 to 3, what's happening? Is it including 3? No, it's not including 3. It's not including 2. So we're looking for height and slope. So I'll say something down here as a note that, v is height. And you don't need to write this. This is notes for you. And a is slope. And I'm checking to make sure that they have the same sign. So v on that interval for heights, all the heights are negative. They're all below the t-axis. So v is negative. V is less than 0. What about a? A is slopes. All the slopes here are positive, positive, positive slopes. All of them are positive. So a is greater than 0. So we have our answer. Now let's go ahead and type this one out. So we say that the speed is decreasing because they're opposite signs. So the speed is decreasing on that interval from 2 to 3 because for each t in, well, I'll just say because all, how do I want to say? I'll just say because v and a have different signs. No, I think that's enough. Yeah, that's good. How to score yourself. Let's come up here. You score yourself. You give yourself 1 point if you said that the speed was decreasing. So +1 right here. And +1 if you say v and a have different signs. For part D, on what time intervals is the acceleration negative? So again, acceleration, I'll write it down. Acceleration is slope. So it's asking, where do you have a negative slope? Come back up here to the graph. We'll have a negative slope up until, and it tells you at time is equal to, there are horizontal tangents here. The information that I haven't used yet is that t is equal to 1 and t is equal to 4, which means I know at 1 there's a horizontal tangent, and at 4 there is a horizontal tangent. Those are the boundaries of the change of slope. So the slope is negative between 0 and 1 right there, and then positive, 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 and then negative between 4 and 6. So those are your two boundaries. You can kind of see it up there in the graph. I'm going to type out my answer. It'll be a little bit faster now. So a is negative on 0 to 1 and 4 to 6 because the derivative of velocity v prime of t is less than 0. And again, the derivative of velocity is acceleration, or I can think of that as slope on these intervals. All right, now the multiple choice, and this should all now be review. So whenever I have the, oh wait, I didn't score myself, come back. To score yourself, this one was out of 2 points, out of 2 points. That one was out of 2 points also, out of 2 points. You get 1 point if you said both of those intervals, so +1 if you said both of those intervals, and 1 point if you said something along the lines of the slope is negative, or the slope, you have to say the slope of velocity, you can't just say the slope, or v prime of t is less than 0. Either way, you get a point. How many points was it out of 2? Plus 2 is 4, plus 3, so this one was only out of 7, all right. And then number 4, now we go on to these. Whenever I have the limit as n goes to infinity, I'm always going to be using my top-bottom rules. Here's your review of top-bottom rules. If the top exponent or the top power is bigger than your bottom power, then it's going to be does not exist because it's really going to infinity, right? So I'll put infinity in parentheses, so it would be non-existent in that case. If the bottom is bigger than the top, so the top is lowercase, and the bottom is bigger, that's going to be 0. And then if you have the same sign, so the top and bottom are the same, then you're going to do the magic fraction. Can't spell magic fraction. And magic fraction just means look at the coefficients. I'll say coefficients. So let's look at the highest power. The highest power is 3. The highest power is 3. Okay, the top and bottom have the same degree, the same powers, which means I can ignore all this stuff. I love crossing things out. And then I'm going to do a magic fraction. Magic fraction, again, look at the coefficients. The coefficient is 3, coefficient is 1. The answer is 3 divided by 1, which is 3. Correct answer is D. On to number 5, the slope of the line tangent. You might be thinking, oh, line tangent, that's going to be y minus box is equal to... Okay, you're doing too much work. I'm only looking for the slope. The slope of the line tangent is just the derivative. So take the derivative of this, plug in 4, you'll get your answer. So the derivative of natural log is 1 over whatever this is. Another way of saying the derivative of natural log is take your inside and flip it. So the derivative of natural log here, y prime, just of this function before plugging in 4, is I flip whatever's on the inside, which is 2 over x. That is Dowder. Then I multiply by the derivative of the inner. What is the derivative of x over 2? That's 1/2. So times 1/2. That is Dowder, that is dinner, and then you can clearly see that the 2's are going to cancel out, and I'm going to be left with 1 over x. Okay, now I'm going to plug in 4, and I get 1 over 4. It was that easy. All right. So the answer is B. Let's go on to number 6. Okay, so these are all graphs of y. So on a graph of y, what is y prime? Y prime is going to be slope. On a graph of y, what is y double prime? That's going to be concavity. So the slope is greater than 0. That means the slope is positive. Concavity is less than 0. That means it's concave down. So I'm looking for something that only has positive slopes and always have concave down. So positive slopes, that immediately gets rid of C. That immediately gets rid of D because I have a negative slope right here. All right, now I can only be concave down. Well, that's clearly concave up, so no. This one is concave down, looks okay, maybe. This one is concave down here and concave up here. It can only be concave down, so the correct answer is B. On to number 7. All right, so this one is looking for, and it got cut off a little bit. I'll have to move this calculator symbol down so it doesn't cover that. It's the line tangent of the graph of f. So I need the entire equation of the line. So that's going to be the y minus box. I'll make that box slightly bigger. Y minus box is equal to box times x minus box. And again, what goes in these boxes? Your x coordinate goes in this box, your y coordinate goes in this box, and your f prime of whatever your x was goes in that box. So whatever this x goes, plugs in there. Don't know why I hit undo. Okay, so from here, I need to figure out what my x is. It tells us it's -1. All right, plug in -1. All right, and when I plug in -1, I can get my y coordinate out just by plugging in each of these x's as -1. So let's go ahead and find that. So your y value is going to be 4 of -1 to the power of 3 minus 5 times -1 plus 3. Negative 1 to the power of 3. Anytime you have an odd power, it's always going to stay negative, so it's going to be negative here. Negative 4 in this case. So let's come down here to yellow. Negative 4, and then negative 5 times negative 1 is a positive 5, or plus 5, and then plus 3. 5 plus 3 is 8. 8 minus 4 is 4, so y is equal to 4. Come back up here and say y is 4. All right, and then I'm going to take the derivative. I need to find f prime, so let's take the derivative really quickly here. So f prime of x is going to be equal to, 3 comes down, 3 times 4 is 12. X goes down a power to 2 minus 5. All right, and then I'm going to plug in this negative 1 into my x, and I get 12 times negative 1 to the power of 2 minus 5. And I guess I can show my work. This is f prime of negative 1 in this case. Negative 1 to the power of an even is going to be positive, so positive 1 times 12 is 12. 12 minus 5 is 7. So I know that my slope up here is 7. I just need to rewrite all this stuff. Oop. So rewriting all this, this is now going to come down here, and it's going to be y is equal to 7x. Again, double negative is going to turn into a plus, right? So plus 7. And then I need to add the 4 to both sides for my final step, so plus 4. So all of these have 7x except for D and E, and then 7 plus 4 is 11, so it's very clearly C. All right, and then on here to number 8, our final problem for pretest number 7. I'm taking the integral of this function. I always assume taxman. Even if you didn't need to use taxman, you'll still get the problem correct. This one is clearly taxman because I'm in powerhouse. Inside of the powerhouse is 3x plus 1. The derivative of the inner, the dinner, is 3. If the dinner's 1, you didn't need to use taxman. The dinner here is 3, so I did need to use taxman. I need u, which is 3x plus 1. I need taxman, which is, there's no one. And I need the derivative of this u up here, which is 3. That means I'm going to pay taxman 1/3. After I pay taxman, I have the permission to take the antiderivative. So rewriting with paid taxman, I have 1/3 times 3x plus 1, all to the power of 5 dx. All right, I now have permission to take the antiderivative. So I still have that 1/3 out front. This is still going to be, I'll leave some space here. This is still going to be 3x plus 1. Now to the power of, it goes up a power, 6. And then divide down. So I can divide by 6 like that, or I can just say 1/6 like that. And then don't forget your cake, plus C. All right, so I'm looking for something that has 1/18 on the bottom. And the only thing that has 1/18 is A. A is our final answer. And that concludes pretest number 7.